Hello all, this is Manjusha Bhosale from KK Polytechnic Nashik. Today we will see the concept of free space management, which is under memory management of the operating system. The objective of this video is to understand free space management technique for secondary storage. Free space management techniques includes two methods. First is bitmap or bit vector and second is linked list. Before discussing these two methods, we will first discuss the meaning of free space management and then we will discuss these two methods. Now, whenever we think about the secondary storage, it is nothing but the collection of blocks. The blocks are having some same size and on that blocks the files are stored. Since the disk space is limited, we need to reuse the space from deleted files if possible. For example, if I want to create a file, at that time it needs some space and at that time I need some free blocks. So where to find all these free blocks so that I can create a new file is nothing but the free space management. For write once disk, it is not possible to erase the data and write the data again, but secondary storage is rewritable. You can create so many files and whenever you delete some files you can use or reuse that space again and again. To keep the track of free disk space, system maintain free space list, which lists all free blocks which are not allocated to any file or directory. To create a file, we have to first search the free list and allocate that space to the new file. The allocated block number is then removed from the free space list, and when file is deleted, the space is added to the free space list. Here I will give you one example. Suppose on my secondary storage there are 10 blocks, out of 6 blocks are already occupied and 4 blocks are free. That 4 block numbers will be listed in the free space list. Whenever I want to create a new file, I will first find out the free blocks in that free space list and then that will be occupied by me and that block numbers will be erased from the free space list. And whenever I will delete some of the blocks or some of the files on that secondary storage, then that deleted block numbers will be added to the free space list. Now how is that possible, that we will see. The first method is bit vector or bitmap, which maintain the number of bits for number of blocks. So if you have n number of blocks, we have to maintain n number of bits. For each block we have to maintain either 1 or 0, that is only one bit will be maintained for one block and that one bit may be 0 or 1. If it is 1, it means the block is free, and if it is 0, then it means block is occupied. So if I have 256 blocks, then I need to maintain 256 bits. Now the question is where to maintain these 256 bits. So these bits are maintained on the same secondary storage, and for that we need some extra space, that is one full block will be required to maintain these bitmap or bit vector. For example, here we can see that we have 0 to n minus 1 blocks and for each block one bit is maintained, but for that block some index is given or there is block number. So when we specify the bit vector also has the index and that index specify or indicate the block number. So if total blocks are 2 raised to 10, that is 1024, we need to keep 1024 bits as a bit vector, and to store all these bits we need one block if the size of each block is 512 bytes. If it is more, then sometime it may happen that we need more than one blocks. So this is the disadvantage of this bit vector, but there are some advantages also. It is easy to get contiguous files. So suppose if I have bit vector and if I found contiguous ones, then that will be treated as a contiguous space and that will be allocated to contiguous files. It can be implemented using vectors or array, and it is easy to implement and it is efficient. Efficient means it is easy to find out the free blocks. Whenever you will just go through the bit vector, the ones will indicate the free block, so that block number according to the index of that bit will be treated as a free block and that will be given to the file. Generally these bit vectors or bitmaps are used by Apple Macintosh OS, and if you want to reduce the size of bitmap, we can use the grouping. So if you have 8 contiguous ones, you can make it 1. If you have zeros, contiguous zeros, then you can group them together to indicate that the blocks are occupied. But whenever you want free blocks, at that time you need to keep that bit vector on the disk, and whenever you want to read that bit vector, it should be in a main memory. So sometime the copy in the main memory and the disk may differ, so that is the complication with this method. So there is another method that is called as a linked list. Here in the diagram we can see that linked list is maintained like there is a free space list header which contain the address of first free block, and then first free block contain the address of next free block, and likewise the linked list is maintained here like 2 3 4 5 8 9 10 11 12 13 17 18 25 26 and 27 is the last free block which is grounded, and it means it is last block. Now whenever I want to create a new file, I will just go through this free space list head, and then how many blocks I need, that many blocks I will occupy, and just I need to update the pointer. But maintaining and updating pointer is somewhat difficult task, so this linked list also has some advantages and disadvantages. Whenever we want contiguous space, it is not easy in the linked list to find out contiguous space, because in any case you have to go through the linked list, and we cannot find out that how the addresses of the blocks are maintained, because you just have to follow the pointers. So to find the contiguous space or contiguous blocks, we need to observe the address of the block or number of the block. But one thing is there, that there is no waste of space, and random blocks are used for creating the files or to storing the files. But here we need to protect the pointer to free list. No separate method is needed for pointer. FAT is used for it because FAT, that is file allocation table, easily maintain the pointers, and we need to traverse each block, hence it require the IO. Each time whenever we want to create a new file, at that time we have to traverse through whole linked list, and then whatever blocks we want, that we can use for our files. So this is somewhat a difficult task, and as compared to bitmap, it is difficult to implement. So from these two methods, bitmap or linked list, bitmap is somewhat simple but it needs more space, and linked list is somewhat difficult but it does not waste the space. So this is all about free space management in operating system. Generally this concept is applicable for secondary storage, because on secondary storage we want to rewrite the data and we want to use the blocks again and again. So there is some technique to find out the free blocks, and these are two techniques that we have discussed today. So this is all for now. Thank you.